Hello everyone, and thank you for joining in on our introductory webinar on insulation. My name is Eric Bensala. I am an energy advisor for OPPD. If you have any questions by the end of this webinar or would like to learn more, please feel free to send me an email or leave me a voicemail. In this webinar, we are going to look at insulation's function as well as the types of insulation out there. From there, we'll look at the places in the home you can insulate and what effects insulation has. To close out our insulation webinar, we'll go over some elements for you to consider with respect to insulation, and as usual, we'll go over some resources. Insulation's function sometimes gets lumped into the conversation about sealing a home up. However, this is not a function of insulation, except in the case of spray foam insulation, which we'll get to in due course. The main function of insulation, however, is to slow the flow of heat from one area to another. Like all energy-efficient measures, insulation has a measurement. We call this R value. This is a measure of the insulation's ability to resist heat traveling through it. In other words, slowing the flow of heat from one space to another. How to read and understand the R value is pretty straightforward. The higher the R value, the better the insulation is at that reduction of heat transfer. Here we have a map of the U.S. and all its counties. Each colored zone indicates the amount of insulation required within that particular zone. As you can see, the zones are broken up pretty evenly by region, with some exceptions such as mountainous terrain. OPPD's service territory is in that green zone, or Zone 5. Using this chart, we can see what amount of insulation is recommended for Zone 5. In an uninsulated attic, anywhere between R49 and R60, if that attic has roughly 3 to 4 inches of insulation already, adding R38 to R49 is recommended. And lastly, for the floor, we see R25 to R30. Going back to the attic insulation recommendation, I want to address something about adding to existing insulation already rated at R49. If your attic has already R49 insulation in it, it is not necessary to add insulation to get it to R60 when it comes to the energy savings of that measure. If you don't have insulation or are fully replacing your insulation in the attic and want to go straight to R60, you can, but the upgrade of adding to R49 does not have a significant payoff. Alright. We have some information in our back pockets on how insulation works. Let's look at the different types of insulation. Our main insulation types come down to blanket or bat rolls, spray foam, loose fill blown-in insulation, foam board, and reflective or radiant barrier. Bat insulation is relatively inexpensive when compared to the other applications. While bat insulation materials have improved, it is still a good practice to wear eye, mouth, and hand protective gear. Bat insulation is one of the easier do-it-yourself applications, but a key point to remember when installing bat insulation is to never pack it or force it to fit. Always cut out spots for things like electrical boxes, plumbing, and any other items that may be in the cavity you're installing the insulation in. Bat insulation is great for long cavities like in between wall studs of an unfinished wall or between the joists in a floor. We'll look at how we can do this later on. Spray foam is that exception to the air sealing situation. Due to its composition and application, it can be used to seal leaks and gaps while still having insulation-oriented properties. This is one of the more expensive applications as it generally requires a professional to do the work. The application of it comes out like a thick, clumpy liquid, but expands into a solid. Another blown-in application is the loose fill option of insulation. This is the type of insulation you generally see in attics between joists and rising above. Loose fill insulation can either be a do-it-yourself project or you can hire this type of work out. Again, as with any do-it-yourself job, especially with insulation, protective eye, mouth, and hand gear is highly recommended. One of the small drawbacks of this type of application is it can have settling issues which professionals can generally help alleviate and work out, though over time the insulation will end up settling, which is why we went over that map a few slides ago and what amount of insulation to add in those situations. Foam board insulation is mostly used in new construction, but can easily be used as a retrofit option. Foam board is great for walls, floors, and joists of all kinds. It is very easy to cut to size and apply. It also is one of the most efficient forms of insulation when it comes to reducing energy. Radiant barriers are a little different breed of insulation as they are more for reflecting heat away from the home. Essentially, they reflect heat radiation coming toward them and impede the heat flow by being poor emitters of heat radiation. Now, with that being said, a radiant barrier's R value does drop quite a bit with air convection, that is, air traveling via a gas. This presents a problem in using radiant barriers as insulation. In order for them to be effective as insulation, they must face a calm airspace, essentially one without air convection, though it is difficult to achieve. Alright, we're building things up here. Let's look at where we can apply these types of insulation in our home. Unfinished attic spaces are one of the most common places to insulate. Exterior walls can be difficult if they're already finished, but in renovations or new construction, batt insulation and spray foam are the best applications. There are some companies that can add loose fill blown-in insulation to your existing walls with a little skill and ingenuity. Floors above cold spaces, in between the joists, like in an unfinished basement, batt insulation without backing is perfect here. Band joists, rim joists are easy spaces to insulate. And definitely, if you have a crawl space, batt insulation works great here in between the joists. Let's expand on each of these. If you've never seen your attic, this is a good time to check and make sure it has adequate insulation. To get a good idea of how much insulation your attic should have, the general rule of thumb is to have enough insulation to fill the joist cavity and above it by a few inches. In the photos here on the left, we see inadequate insulation. This is roughly the equivalent of R18. This is a situation that will need to have insulation added to it, if not removed and all new insulation added. On the right, however, we see a representation of how deep the cavity is and how much is required above the top of the joist. That's where we want to see it in the attic. In this photo, we are seeing about an R38, but here in eastern Nebraska and western Iowa, a few more inches on top of that to R49 is best. Exterior walls can be a challenge for insulation when in a finished home. There are ways to insulate an already finished home's exterior walls, but that can be cost prohibitive. It generally involves small holes drilled at the top of each cavity area and loose fill insulation blown into the cavity. Now, with that being said, if the wall is not finished yet, batt insulation is a very easy and effective application here. As mentioned before with batt insulation, it is crucial to make sure you don't pack it or force it to fit. If there are any obstructions like electrical boxes, wires, or plumbing, cut the insulation around these obstructions to allow the insulation a nice clean fit. Batt insulation's effectiveness diminishes if it's packed or scrunched. We have two places to insulate in this photo, but we'll start with the floor above this workbench here. Fiberglass batts of R25 are perfect here, but also you should install unfaced batts. These are a little trickier to work with than faced batts. Unfaced batts essentially don't have the paper backing to them. You can even find batt insulation that has perforated facing. This helps reduce the possibility of trapping any moisture you wouldn't be able to see. Some other things to keep in mind are to ensure there is no space between the insulation and the floorboard above. To keep insulation up in the joist, wood lathe supports or wire work well versus stapling the backing to the joist, which can cause the insulation to sink off of the floorboard. The other area in this photo is the rim joist. As you can see in the zoomed-in inset photo, the rim joist is already insulated by small, cut-to-size batt insulation. You can also use cut-to-size foam board with some caulking to really help seal them in. Rim joists can be a significant source of heat transfer in a home, whether that's in the summer or the winter. With the image on the right, on top we have a carpeted floor with some drywall, batt insulation, a thin piece of wood, and then the siding. But below the floorboard, we have that rim joist sitting on the sill plate. In this example, we have rigid foam board in place with some caulk to seal that area up. Now, instead of just the rim joist, wood, and siding, we have some insulation in there too. Crawl spaces are very similar to the floors above finished areas. The same method of insulation applies here, but moisture management should really be taken into consideration due to their tendency to trap moisture without proper ventilation. Just as you would with the floors above cold spaces, ensure there is no space between the insulation and the floorboard above. Keep the insulation up in the joist using wood lathe supports every 18 inches or so, versus stapling the backing to the joist, which can cause the insulation to sink off of the floorboard. So, with insulating your home in different areas, what are the effects of this work? The primary benefits to installing and or upgrading your insulation is that it will help your home become more efficient in how it handles the thermal energy that moves throughout it. This helps conserve energy, which reduces your energy bill by allowing your HVAC system to operate more efficiently. When this occurs, the comfort of your home increases. When coupled with airflow adjustments, you can reduce the temperature variations within your home, making you much more comfortable. Some secondary benefits to insulation are, but not limited to, increased structural strength, primarily from the spray foam insulation application of closed or open cell insulation. When the foam dries and expands, it does add some structural strength to the area it was applied to. Insulation is a great noise reducer. While not exactly soundproofing, it does have properties that contribute to the reduction of sound waves traveling from one space to another. And a well-insulated home tends to offer a bit extra on the resale value due to the reduction in energy usage, not to mention a reduction in energy wasted and the improved comfort of the home. The effects of insulation are pretty broad, but really the main effect is to help make our homes much more comfortable, which have added benefits tied in. In this photo here, we have a home in the wintertime. The inset image is from a thermal imaging gun. The brighter the orange or yellow, the more heat is transferring. As you can imagine, windows and doors are terrible insulators. So is a chimney, as you can see. But if you look closely, you'll see an almost white band at the bottom of the home. That is where the rim joist is at. And that is why we spent so much time on it. There is a tremendous amount of heat transfer occurring here. By contrast, the roof looks pretty cool relative to the rest of the home. It's likely that they have adequate insulation in their attic. To close out this webinar, let's look at a few additional resources OPPD has. Our energy efficiency pages at oppd.com/ee have a lot of information about energy efficiency. We have a tips page broken down by topic, do-it-yourself videos, an interactive house to learn more about what you can do in each room to reduce your energy or improve the comfort of your home, and more. This concludes our introductory webinar on insulation. Thank you for joining and have a wonderful day.